Okay, hello and welcome everyone. So in this video, I'm going to do a walkthrough of some oligopoly exercises. And so in particular, I've got two here, but for each exercise, I'm going to go through several things. So for instance, in question one, obviously there's a monopoly component, a Cournot component, and then a Stackelberg component. So two oligopoly and then a monopoly version, all pertaining to this inverse demand curve and this marginal cost. So let me show the question for the first one first, and then let me show the question for the second one before I do anything else. And that way, if you want to stop the video and work on them, you can. So for the second one, I'll study Cournot, monopoly, and then Stackelberg in that order. And here's the inverse demand curve. Here are the marginal costs. Okay. And basically just, I don't want to go over everything because I wrote the solution there, but basically what I'm going to do is ask to find the monopoly outcome, the Cournot outcome, and the Stackelberg outcome in both exercises. All right, so first off, we have an inverse demand curve. Price is given by 160 minus 2Q, marginal cost of 40. So a couple things right off the bat. Firstly, we want to think of any firm in this market is going to have the same marginal cost. And so that's what I'm saying here. So let me just read over this, why we get that. So we have a firm, estimated their market demand, their marginal cost is 40. So constant marginal cost, constant average total cost. They know their startup is the first of the market, definitely be the sole firm for the first year. They're a monopoly. In the second year, it's highly likely that that a rival will want to enter the market. So here we have like a former classmate who's ended up launching a product. Maybe they overheard discussions at a study table or whatever. Anyway, so now we have two firms splitting the market as identical Cournot oligopolies. By identical Cournot oligopolies, we interpret this as meaning, since they face the same inverse demand curve, and since this 2 is going to be multiplied to both of their quantities, I'll talk about that in a second, all we need for identical Cournot oligopolies is that they have the same marginal cost. So on the basis of me saying that the rival is going to be an identical Cournot oligopoly, that lets us know that both firms are going to have marginal cost of 40. Okay, so the first thing we want to do, though, is we want to solve for the monopoly outcome and profits. And so I've got this here. Oh, sorry. So I said I'd say something about this. So here we have price is equal to 160 minus 2Q. This is the market demand curve, right? So I'm using this for the monopoly. This is also the market demand curve faced by our Cournot and our Stackelberg firms. So how do we interpret this Q? That's the market quantity. The market quantity is going to be the sum of the quantities brought to market by both of the constituent oligopolies. So matter of fact, let me actually write this up here. I kind of wish I would have put this in the slides initially, but we'll say Q is equal to Q1 plus Q2. And sorry, I don't know if I can, I don't know if there's a way that I can make these subscripts, but anyway, so this market quantity, that's just the sum of the quantity from firm 1, sum of the quantity from the firm 2. So actually, let me say a little bit more here. So what this means then, so whoops, I'll just start over from scratch. This is good radio, folks. Good radio. So Q1 plus Q2 means 2Q becomes 2Q1 plus 2Q2, right? That's just the algebra. And so sometimes, because we so often see the coefficient on quantity 1 and quantity 2 just being 1, sometimes we kind of forget how to deal with this coefficient here. Well, because this is the monopoly market quantity, which will be the monopoly quantity, because it's the market quantity, it's just the sum of the quantity from firm 1 and firm 2, meaning we need to distribute 2 to both of those quantities. So it'll be 2Q1 plus 2Q2 is going to be the quantity component of our inverse demand. So overall, it's going to be price is equal to 160 minus 2Q1 minus 2Q2. And so I'll do that a little bit later on. But anyway, so finding the monopoly outcome and profits, we don't need to worry about that just yet. Here's our inverse demand. So what the monopoly is going to do, they're going to maximize profit. Now, economists like to use pi for profit because we use p for price. So to hopefully ultimately lead to less confusion, we'll use price for profit. Sorry, price for profit. What am I talking about? We'll use pi for profit. All right, so pi of Q is going to be profit in terms of Q. So this is inverse demand. This is price as a function of quantity. That's exactly what this is. Times the quantity. You'll recognize this as revenue minus cost. All right, so this is the revenue component. This is the cost component. It's going to be 160 minus 2Q times Q minus 40Q because we had constant marginal cost. And I'm going to distribute this Q to both. So 160Q minus 2Q squared and then minus 40Q. So I'm actually going to do that algebra before I take any derivatives. So it's going to be 120. So collecting like terms, 120q minus 2q squared. Now I'll take the derivative with respect to quantity, and that'll help us find the monopoly's optimal quantity. And so I'm setting this equal to 0 to get my first order condition for maximizing profit, and solving, sure enough, that quantity is going to be 30. Now we have to find the price. Remember, prices come from demand curves, so I'm going to put this back into the demand curve. It'll be 160 minus 2 times 30, or 160 minus 60. That'll give me a price of 100. One thing that's buried in here is the fact that sometimes I like to give you the shortcut, which is if we have the inverse demand, we can find the marginal cost. It has the same vertical intercept and twice the slope. We do actually have that buried down here. It doesn't look like it, but we do. So the same vertical intercept for marginal revenue as overall demand would be a vertical intercept of 160. Twice the slope would be minus 4 q. We have that. It's this right here. It doesn't look like it. Why? Because this is going to be, we would actually have a 160 minus 40q is equal to 40, but I moved that 40 to the other side here. And so this isn't the vertical, this right here on the left-hand side is not marginal revenue. We've already accounted for marginal cost. And so marginal revenue is always going to be what, same vertical intercept, twice the slope. The other thing you could have done is you could have just, rather than all this calculus, you could have taken 160 minus 4q is equal to 40. And then if you solve, the very next step is going to bring you right here. Right? Okay, so anyway, so we did this already. We got the quantity, we got the price. Profit is going to be price minus cost times quantity. All right, so price was 100 minus the marginal cost of 40 is 60 times 30 is going to be profits of 1,800. All right, so now we'll do Cournot next, and then we'll do Stackelberg. So Cournot is where we have an oligopoly. We have two firms with market power, and they are going to take into consideration the fact that the rival is going to respond to their own quantity choice. And so what this means is when I write out the profit maximization problem for my oligopolist, though it looks a lot like our monopoly profit maximization problem, now what's happening is firm 2's choice has to enter into firm 1's decision. We'll see that a little bit more formally below. But anyway, so my market demand is now going to be 160 minus 2q1 minus 2q2, because remember, q is going to be the sum of q1 and q2. That's from up here. I wonder if I can just bring this down where I need this. I sure can. Sure cannot. Anyway, so here's going to be our inverse market demand. I'll distribute this q, and I'll have 160q1 minus 2q1 squared minus 2q2 q1 minus 40q1. And then cleaning this up, just collecting like terms, I'll have 120q1 minus 2q1 squared minus 2q2 q1. Now I'll take the derivative. So I'll have 120. The derivative of this is just the coefficient on the quantity, because I'm differentiating with respect to quantity 1. Derivative here, you'll just multiply bring the power down, multiply the coefficient by the power. So 2 times 2 is 4. Reduce the power by 1, so it becomes to the first. This right here, 2q2 is a constant with respect to when I differentiate with respect to q1, just like this 120. Relative to the derivative, 120 is the same type of object as 2q2 relative to q1 at the point that I'm taking this partial derivative. Anyway, so what I want to do though is I want to find firm 1's optimal choice. So I'm going to solve this thing for q1, and I've got this right here. q1 of q2 is equal to 120 minus q2 over 4. This is not multiplication. This is q1 of q2 telling me that firm 1's optimal choice is going to be a function of what firm 2 chooses. All right, by symmetry, we know that we're going to have the exact same reaction curve. This is called a reaction curve. It's a best response function. It's telling us firm 1's best response to firm 2's choice, or firm 1's reaction to firm 2's choice. By symmetry, we're going to have the same curve. You could actually redo this problem, but write this out for profit of firm 2. That's a good check. You should do that on your own. And if you do that, you should definitely get the same result that I've got down here. So by symmetry, we had the same reaction curves. Oh, you're staring at this. You're like, wait a second. We had 120 minus 2q2 over 4. Now we have 30 minus 1/2 q. Yeah. So my recommendation is whenever this standalone constant is divisible by, well, is even, it turns out that almost always even, then you're going to want to actually do that division. And so I've got this. So I've done this division. I've got 120 divided by 4 is 30, and then 2 divided by 4 is 1/2. Why? Because later on when I'm substituting in, it actually works a little bit easier because I'm going to have fewer fractions, fewer quotient bars to have to deal with. At a certain level, it's personal preference. Matter of fact, in the Cournot lecture that I gave, I did not do this, but it is, well, I did not do this until later on, but this is the way that I would recommend doing it. All right, so anyway, so we've got firm 1's reaction to firm 2's choice. We have firm 2's reaction to firm 1's choice. Now what I'm going to do is I've got two equations and two unknowns. So I'm going to solve by substitution. Rather than having Q2 here, I'm going to replace 30 minus 1/2 Q1. I've done that there. That's what this arrow is telling me. Now I'm going to clean this up. So this is going to be 30 minus 1/2 times the quantity 30 minus 1/2 Q1. So this becomes 30 minus 15, and then 30 plus, right, minus 30 plus 1/4 Q1. Moving the Q1 to the other side, I end up getting 3/4 Q1. This is just going to be 15. Multiplying through, 4 times 15 is 60, divided by 3 is 20. So firm 1's optimal choice is 20. Let's drop that into firm 2's reaction to firm 1's choice. We're just using this function right here. Whoops, sorry. We're just using this function, this function right here. And so I'll have 30 minus 1/2 times 20, or 30 minus 10 is 20, right? So we have them both choosing the same quantity. That's got to happen. This is our Cournot-Nash equilibrium. It's got to happen because we have a symmetric Cournot. If they had different marginal costs, they choose different quantities, but they don't. And then to find the price, we go back to the inverse demand. 160 minus 40 is going to be 160 minus 80, or just the price of 80. And then we can calculate the profit. So profit is price minus cost times quantity. Sure enough, it's going to be 40 times 20 is going to give us our 800, and our joint profits are going to be 1600. Right? Joint profits are the sum of firm 1's profit and firm 2's profit. Notice this 1600 is smaller than the 1800 profit that the monopolist would have had. All right, the last thing we want to do is we want to do Stackelberg. So now I'm going to do Stackelberg. The difference between Stackelberg and Cournot is that with Stackelberg, we are assuming that the Stackelberg leader knows the follower will observe their choice. So what's going to end up happening, the first thing is, well, if you followed my Stackelberg example video, we see that we're going to expect the leader to sell the monopoly quantity. So by the time that we've solved the monopoly question, we actually know the quantity that the Stackelberg leader is going to set. It's going to be 30 because that's what our monopoly did. Turns out the Stackelberg leader sets the monopoly quantity. The Stackelberg follower sets something smaller than the Cournot quantity. All right, so anyway, so we've got this here. Matter of fact, this was an exam question, one that I was quite proud of, because students that would be pressed for time would be able to get quite a bit of the partial credit, because by virtue of having done the monopoly first and then Cournot, oh, this is where that went to. By virtue of having done monopoly first, then Cournot, then Stackelberg, you actually had solved a large part of what you needed to for the problem. You could kind of, definitely for full credit had to show the work here, but if you really pressed for time, you had the outcome for our Stackelberg leader. And it's certainly worth considerable credit having realized that. Anyway, so start with the realization that the leader anticipates the follower's reaction. Well, the follower's reaction was Q2 of Q1, so 30 minus 1/2 Q1. I'm going to drop this into firm 1's profit maximization problem, right? This looks like their Cournot profit maximization problem to a point. The difference is now, rather than just having Q2, I have Q2 of Q1. This looks like it's Q2 times Q1. Sorry about that. This is Q2 of Q1. This is Q2 as a function of Q1. That's what this is. This is a function, not a quantity, right? The Cournot profit maximization problem, it was just firm 2's choice was entering, firm 2's quantity was entering profit for firm 1. With Stackelberg, it's going to be firm 2's reaction function. This whole thing is going to be entering firm 1's profit function. So I'm going to drop in the reaction function from firm 2. That's this right here. Now I'm going to clean this up. At first, you're looking at this, you're like, this is horrible. And the algebra is not fun at first, but then it becomes really, really clean once we kind of move things around. So you'll see that here in a second. So, all right, I need to distribute this too. Also, I need to not forget to distribute this Q to everything. That's okay. Where do people make mistakes? Sometimes people forget about this Q out here and distributing it through. All right, so I think I actually did that first. I did. So I have 160 Q1 minus 2Q1 squared minus 2Q1 times firm 2's reaction curve minus 40 Q1. Now I'll simplify or clean this up. It'll be minus 60 Q1 plus, well, 2 times 1/2 Q1 becomes just positive Q1 squared. And then just cleaning this up, I end up getting something really nice. I haven't even taken a derivative. Look, no derivative. This is just algebra up until this point. Now I'm going to take the derivative of this thing. That's really easy, right? It's going to be 6. Got it. So quantity Q1 is 30. And put my check mark there because that's what we were expecting, the monopoly quantity. All right, so what's happened now is our Stackelberg leader has made their choice. They've set the quantity of 30, and the Stackelberg follower now needs to react. So the Stackelberg follower sees the monopoly quantity. What do they produce? Not 0. They're actually going to produce 15. Why? Because we'll evaluate their reaction to firm 1's choice of 30. It's going to be Q2 of 30. So our Stackelberg leader sets a quantity of 30. Stackelberg follower sets a quantity of 15. And then the price, well, it's going to be price of 70. We'll calculate the profits for the leader and the profit for the follower. Profit is just price minus cost, that whole thing times quantity, right? Notice our sum of our profits are $13.50. That's even smaller than our joint profits from Cournot. So as a market as a whole, profits have fallen. However, our individual leader has got profits of 900, which are better than they would have got as a Cournot firm, right? So their Stackelberg leader sets the monopoly quantity. They don't get the monopoly profits. Why? Because the Stackelberg follower doesn't set 0. Stackelberg leader is not actually a monopoly. They just set the monopoly quantity. All right. So that was the first question. Now let's do the second question. So let's see, make this a little bit larger. Now I'm all used to looking at large text. This hot chocolate's not too hot anymore. Reminds me of a story. I grew up in Green Bay, Wisconsin, and around 2000, they decided that they needed a new stadium or needed an expansion to Lambeau Field. So they had a 0.5% sales tax in Brown County. And Brown County taxpayers then got entered into a lottery to get Packer tickets. We got tickets for the Detroit Lions game two years in a row. So I went in, it's like 2002, 2003, 2004, something like that, middle of December. It was cold. Bought some hot chocolate, burned my tongue. So I set it down on the bench next to me, and Lambeau Field is concrete. And you're sitting on metal bleachers on concrete. And I forgot about it for a while. We saw like whatever couple series, and then I went back to my hot chocolate. It was probably like 5-10 minutes later, and it was ice cold. Not frozen, but it was cold. So that's why I don't live in Green Bay anymore. All right, so Monopoly, Cournot, and then Stackelberg. So suppose a firm has estimated their market demand, and that's why I'm glad that Detroit has the dome. So anyway. Price is equal to 162Q. Their marginal cost is 40. Oh, sorry. Here I am. Here I'm getting caught up in my. What am I doing? I'm telling stories and getting confused and drinking my hot chocolate. Having a great old time, and I'm gonna lead us right into the question I just did. So it's like a never-ending cycle of just blah. All right. So here's the new exercise we want to do. I wonder how far I would have got before I realized that. Probably farther than I like to admit. So, all right. So, Cournot, Monopoly, and Stackelberg. Consider the following market with inverse demand: 15 minus 3Q1 minus 3Q2. So, let's see. Suppose all the firms in the market have marginal costs of $6, and maybe you're the entrant considering developing the market, but you know of a former friend, who stole your idea and is going to do the same thing. So, we're going to have Cournot. We're going to look at the Monopoly situation, and then we're going to look at the Stackelberg situation. So, the first thing is let's look at the Cournot oligopoly solution. So just using this inverse demand, well, since everybody has the same marginal cost, we'll have symmetry. We're only going to have to solve firm 1's profit or for firm 1's reaction curve, and then we'll know firm 2's reaction is going to be the same by symmetry because we have the same coefficients on Q1 and Q2 and the same marginal cost. All firms in the market will have marginal cost of 6. Anyway, so here's firm 1's profit function, right? So 15 minus 3Q1 minus 3Q2 times the whole thing times Q1. This is revenue. This is minus cost. We'll distribute this Q1 to everything. So 15Q1 minus 3Q1 squared minus 3Q2 Q1 minus 6Q1. And I'm going to clean this up so it becomes 9Q1 minus 3Q1 squared minus 3Q2 Q1. All right. So now I'll take that derivative. And so it'll be 9 minus 6Q1 minus 3Q2 is equal to 0. Solving for Q1, because we want firm 1's optimal choice, it'll be as a function of Q2. That's this right here. And notice what I've done is I could have written this as, I could have written this as 9 minus 3Q2 over 6. But instead I simplified it down, and though I'm working with fractions here like 1.5 and then 0.5, I would rather deal with it this way because then I'm going to ultimately have fewer quotient bars to deal with. So firm 2's reaction curve is going to look just the same. So by I actually showed this over here. So sorry. So here indeed was firm 1's reaction. Here's firm 2's reaction to firm 1's choice. They're by symmetry, they're essentially the same. Now I've done that division because what I'm actually, so the other thing you could do is we're solving by substitution. You could drop in this whole quotient for Q1 or Q2 here, and then you've got a lot of these large quotient bars to deal with. And so that's just there's a lot more room for error, I think, doing that way. So I just rather take care of this division immediately before I do the substitution, as I've done here. All right, so anyway, so I've substituted for Q2, and now I'm going to distribute this minus 1/2. And so I've got minus 3/4 plus 1/4 Q1 is equal to this Q1. And then solving, well, I find that Q1 has to be equal to 1, Q2 has to be equal to 1. Right? Okay, so how do we know Q2? All right, so suppose Q1 is 1. We'll drop in 1 here, so this will be 9 minus 3 is 6/6 is 1. Right? All right, so we can find the price that's associated here. It's going to be 15 minus 6 is 9. And then profits is going to be price minus cost times quantity. Right? So it's going to be profits of 3 for both firms. Joint profits are 6. All right, now let's find the monopoly solution. So the monopoly solution is just take this inverse demand. So this is price, this is quantity, so this whole thing is revenue minus cost. I'll just simplify down distributing. Now I'll take my derivative, so it'll be 9 minus 6Q is equal to 0. And solving, we find the monopoly's optimal quantity is 1.5. That makes sense. It's bigger than the individual Cournot quantity. And the price, a little bit higher too. It's going to be, we're going to have a price of, end up having a price of 10.5. And monopoly profits are going to be 6.75, right? There's more profits in the market when served by a monopolist than jointly by Cournot firms. Here, joint profits would be 6. Here, monopoly profits are 6.67. All right, now I want to solve the Stackelberg problem. So as before, let's drop in, instead of Q2, we have Q2 of Q1. So I'm going to put firm 2's reaction to firm 1's choice into firm 1's profit function. Note, this gives me pi 1 as a function of Q1 only, which is beautiful. Now we'll do that algebra to simplify this thing down again. And the first thing that I saw is like, why don't I just cancel this 3 right here? And that'll simplify things down nicely before I do anything else. And then I wrote this as minus 4.5. 9 halves is 4.5. And then, let's see, this is a minus becomes a positive 3 halves Q2. Or sorry, Q1 squared. And then just cleaning this up before I take the derivative, it'll now be 4.5 Q1 minus 1.5 Q1 squared. Taking that derivative, 4.5 minus 3 Q1, and then solving. Our optimal quantity for our Stackelberg liter is 1.5. Oh, wait a second. Our optimal quantity for our monopolist was 1.5. Sure enough. And then what does the Stackelberg follower do? Well, we can find the follower's reaction to the liter's choice, and that's going to end up being a quantity of 0.75. Price in this market is going to be 8.25, and then profits to our liter is going to be 3.375. Profits to our follower is going to be 1.6875. I can't see it. I'm staring right through my microphone. So anyway, we see profits for our Stackelberg liter are higher than they would be as an individual Cournot firm, though joint profits are smaller, right? We sum these up. All right, so here we end up with here we reach the end of the video. This is just my typed up solution, so I'll just show that to you for the sake of the video. Hope you liked the video, and then have a good night.